it is already very late, but I just do this, go through all the questions of the final. If you need it, so you can, use it to help you improve your grades. Another thing is, even if you submit a little late, I will not put any penalty on it. So you can use a little more time. All right, so let's start. Part 1, question 1 through 8. All right, the first question. Can we say that Intel 80x86 architecture is a pure RISC architecture? Here, you need to, pay attention to this pure architecture. Okay, yeah. So we learned the special structure, right? Yeah. So you can get that easily. Yeah. The second one, which of the following architecture has more complex instructions? Complex, we know one instruction can do, several different operations. So relatively more complex. Yeah. Another thing is, the more complex, it does not mean more advanced. Yeah. So do not try to connect that. Yeah. More complexity of the instruction, not necessarily equivalent to more advanced. So that's one thing. Yeah. So another thing is also the background, compiler's role, right? So here, there is compiler's role in this whole thing, because compiler will do the translation. Okay, the compiler can do a lot of work. Yeah. So anyway, so based on that background, so you can answer this question easily. Yeah. So number 3, is it possible there exists special RISC architecture that supports variable length instruction? Yeah. So we know RISC architecture typically fixed length instruction, right? Typically fixed length instruction. So here the question is there any possibility? Yeah. We know for the RISC architecture, so it is a big class of architectures. So many different architectures belong to that. One, we know MIPS, right? MIPS is one. Yeah, we learned that, the details. Another ARM, mobile phone, right? Yeah, and many others. Okay, yeah, many others. But among all those, is there a possibility there is a special case using variable length? So in my video, one place, I talk about that. I didn't write it out on my notes. On my notes, you cannot see that. But in my video, I use a few sentences. I describe something special there. Okay? Yeah. So based on that background, when I talk about ARM, I, give you a little more information about instruction length. Yeah. So this is based on that background. Next question, number 4. Can we say that the RISC architectures belong to the load store architecture category? Load store, you know the meaning, right? Only memory access. So here, the meaning. Only memory accesses through load store instructions. Okay? In other words, ALU instructions do not access memory. That's simple. ALU instructions never access memory. That's the load store, the meaning, architecture. Yeah. So now you look at, RISC architecture. if it has this property or not. Number 5, is it possible that the register memory architecture could be low store, right? You just need to know the meaning of register memory. Yeah, we have example. We have one example show you how to use register memory architecture to do a simple operation. We use C equals A plus B, right? Yeah. So from that example, you can see the answer here. Yeah. All right. So next one. How many different addressing modes are used in the MIPS architecture? Yeah. So when you count the different addressing modes, so remember, two parts, right? Two parts. One, memory access. So those instructions can access memory. So number of addressing modes. Another, non-memory access. Those instructions do not access memory, addressing mode. So you put together. Yeah. All right. So the last page of this part, number 7. The MIPS architecture never allows that a memory address is encoded into the instruction directly. Yeah. We know. One instruction word. Certain number of bits. MIPS, we use 32 bits, right? Yeah. 32 bits. Okay. Among 32 bits, so here it says you never use part of the bits to store memory address. Look at this, if the MIPS architecture has this property or not. That's the meaning, okay? Yeah, the last question of this video. In a MIPS instruction, the opcode field always contains the code for a valid operator. Valid operator. Here you need some background. Yeah. So in our 3 types, right? Yeah. So I type, R type, J type, 3. Look at that part. Okay, yeah. Opcode, so remember when we talk about opcode, we have the, primary opcode, primary. Then there is secondary, right? Yeah, secondary. The secondary different from the primary. Okay, primary we use the opcode field. Okay, so that's the primary. Second, we use a different field. Okay, yeah. So based on that information, yeah. So hope you can get the answer. Yeah. All right, so let me finish video part 1 right here.